Hello and welcome back to compiler programming. This is actually the second attempt of me trying to make this video, and this is what I would like to start with, because the first attempt lasted for about 2 hours and then failed miserably until I had a good sleep and came back to it. The problem is, in the last video I actually made an error, and that error was really hard to debug because it's just looking at the raw memory and trying to figure out what's going on and try to figure out what the hell is happening. So here it is. If we go to hello world, like this is our example, right? And then it was something along the lines of I is 42, and then I would have unreachable in here, right? And then if we try to let's edit configuration, yeah, this is gonna be hello world mass. Okay, we try to run this, we get into our debugger, we do print I, we get our 2a, which is 42, and everything is happy. The problem is this works by accident. It doesn't actually work correctly, and we can sort of see that probably if I add something like n is, I don't know, 21, let's try to rerun this, and I would say print I, and here we go. I is still 42, but we got 21, right? Because it's a hexadecimal coding, so this is 21. So the problem is this doesn't actually work. What it does is rather weird, and I'm kind of surprised it shows anything reasonable in here, because once I started to implement what we will work on later today, it would show complete garbage, and I just couldn't figure it out for a very long time. So here's the issue. If we go back to our code and we look at this piece right here, it looks kind of reasonable, and when I was writing it I was pretty sure that makes sense. We say that we get the register memory, and then we offset from that memory, and everything is great. The problem is that this is, completely wrong. Because in here this memory does not point to where the register points. It points to where the register was saved during the exception. So it basically points to a part of context record, but we want to actually look into the value in the register, and that is where we need to point to in terms of memory, both actually in here and in here. And so yeah, debugging this was complete hell, and it took me just getting away from the code to realize what was happening. But what I actually need to do here is to say const void star like this. So what is returned to us again is sort of the value of the register, but we need to actually sort of dereference that register to get to the memory itself. And the same thing over here. So hopefully now if we run our thing and we say print I, we get even bigger issue in here. And the issue now that we are running into is that this calculation isn't correct. I think this will work perfectly fine, but this calculation is inverted in a sense. This should be, it's either should be minus, or we will need actually more data to take care of it. I actually have this fixed in the branch, so now we'll try to debug it again, but we'll go from this, right? So it's either minus or we need to do more work. Let's try. Okay, so it's not minus, but the fact that we are running into CCC is good memory. That means that we are in the right location. We are looking at the stack. So let's get to here. Let's look at what this is. Printf percent d stack offset. Actually, I probably want percent x, not percent d. And you still get to look at me debug for a tiny bit because I don't remember everything, but I do know that we are not in the right location. Okay, so this is a negative value, and I want to know what is the positive version of it is. Print I. Yeah, the positive version of it is 18. Yeah, and the actual issue now is that we are not taking into account the size of the reserved memory from the function itself, right? Because what should happen here is this stack offset is sort of offset back into the reserved space, but we first need to move forward, and that move forward is missing. Now, we need to get to that move forward, and to get to that move forward, we need to get to this thing, I believe. Yeah, we need this stuff over here. So we're gonna take this, and we are going to put it where? Even more down. We're gonna put it right over here. I will eventually refactor this, but for now, we're just gonna, march on. Instruction address is context record rip. Let's create a local JIT. Is this kind of thing. Okay. If runtime function is okay. Yeah, sure. We can say that variable printing is not available in external code. At some point we might want to implement this, but for now that's perfectly fine. And in here we just do this, and no, actually we don't care about this part. Okay, we probably don't care about this part either. What we were looking for was this builder, and we now need to pass this builder. Actually, we could do it later, but whatever. Builder needs to be passed to print value. So let's say context builder. Okay. Let's take this. Let's go in here. Let's take this. Say we have builder. And now, getting back to our stack thing. So we need to say something like effective offset is builder stack reserve, and then there is a big question if it is plus or minus. Like, it always breaks my brain, but I believe it is something along these lines. And now I already roughly know how to debug all of this, so we will figure it out. But I guess we don't need to, because that seems correct. And what was n? Yeah. All that now is fine. Great. So let's commit this separately. Okay, we don't need to that file yet. We also actually don't need this. I don't want to commit this stuff. And here we will say the following: fix stack and indirect memory storage memory in the debugger. Okay, so that's a nice fix, and this file is actually something that we will now work on, and it's from my original attempt at recording this video. Now we need to edit configuration, and we need to go to debugger over here, and now we more or less starting from where I got stuck previously, because what is inside of this file, let me show you. We have a bunch of weird stuff which we actually don't need, but we can keep it out. Here we can say 0, doesn't really matter. But the point of today's video, as you saw from the title, is to work on printing structs, right? So let's do just that. Let's print structs. Where's our struct stuff? Here's our structs. And let's verify that that's where we get to. So if I say, oh, I really wish this would autofocus. Maybe there is a setting for that or something. Okay, to do support structs. Yeah, we are in the right place. So let's begin. We can say, so if I say descriptor, struct, right? Fields, yeah, okay, so that's an array. That means we need, for I0, I less than dynamic array lengths of this stuff, plus I, and then we can say that const struct field is array get of this one and I, right? And what do we have inside field? Inside field we have a descriptor, we have offset, and we have a name. Sounds legit. First thing I guess we want to do here is we want to print like start and end of the struct. And now we need to start printing things. So we need to print the name. That would be dot, then we need ampersand, and we need this incantation, and then we need even more incantation. Slice expand printf. We just, what this is just sized string printing. This is how you do it in with printf, and then in here I'm just sort of expanding to two arguments to printf because we need to provide the string, the size and the string itself. That's what it does. Okay. Here we say field name. I mean, let's just try this out. That would be already nice. Okay. It is kind of okay. I'm missing this. If I is not 0, then printf comma space. All of this is completely inefficient and stuff, but honestly in the debugger it really does not matter how fast all of this is. So I'm doing pretty stupid things in terms of printing. Okay, let's try again. Print. Oh, okay, cool. We are starting to look kind of nice. Next, we need to print the actual values of this. All right, and that means we need to extract some of it actually, because we'll get the descriptor for the actual value inside, right? I guess still here. And then we say static void mass print value with descriptor and memory. To pass a descriptor, and we need to pass memory in here. Sounds good to me. Where was it? In here. Well, value descriptor and memory. We don't need this stuff anymore. Let's try again, since we did a bit of refactoring. And now everything exploded, as you can see in here. And why did that happen? Oh, I actually accidentally removed the wrong thing. Or was overzealous with this stuff. Fine, we can repeat this. Dot percent pre-slice slice expand printf of field name. Much better. Okay. So we factored it out, and the reason we factored it out is because in here I need to actually add equals, and then we need to recurse. We need to say mass print value with descriptor memory, struct, sorry, not struct, field descriptor, and offset, right? Yeah. So here we need to say field memory, and const void star field memory is, you know what? I think I want to change this to this, so it is easier to do calculation and I don't have to constantly do this kind of stuff. Yeah, I think I like it. And we can say const star, by the way, it also is fine, doesn't really matter. And in here we say memory plus field offset. And I think that's basically it. If we are lucky, then this is all we need to do. Print. Oh, look at that. We have printing of structs. Sort of. Now the fun part begins. And the fun part is making sure that this doesn't explode. With structs or any kind of recursive structures, you have a problem that you might end up with sort of too many levels, and or if the struct contains cycles, this also has to be detected. I think I will not deal with cycles today because if I implement the depth limit, then it doesn't matter if you have cycles, eventually it will stop. So let's say support or catch cycles, but what I will do is say U64 depth. I need a comment here, and then I will say if depth is more than whatever 3, 5, I don't know, some arbitrary number. We will say print f dot dot dot, and that's about it. Or maybe like this. Actually, I need to also return here, so let's do it like this. Yeah, if that's more than 5 now, we just need to update whoever calls it. So here we say depth +1, and here we say 0. I didn't want to go in here. It's also not the right button. Nothing should actually change because obviously our stuff is too small. We can try to check that this works by doing this kind of thing. Nested is this, right? And oh, okay. So first of all, nested printing works. That's already good. But now I can go back and in here just say more than 1. Yep. As you can see, now we just say something inside of it. And I think this is a perfectly fine solution to this for now. Cycles, it's a bit more involved to set up a test case for it. And test case is actually maybe something I will work on next because I'm not particularly happy with the current way testing is done. But that's definitely going to be in the next video. For now, what else can we do? Well, we can maybe, what can we do? We can do a pointer. Pointer is an interesting one. I need to think about how I want to print this because I think I want to print the type, and printing of types is a separate bag of cats. Let's maybe try to do fixed array. Debugger, okay, and we say R is whatever I64 times 2, and then 1, and then 2. Okay, print R to do support arrays. Great. Let's try to do this. Arrays have sort of the same style, which might not be great. Maybe I want to be more explicit, but that's something for me to figure out later. So I guess in here we say descriptor fixed array length, and then what is items? Okay, so items is a descriptor. So const descriptor star item. Descriptor is this, right? And then we need to say 64 item byte size is descriptor descriptor size. I'm actually not sure. We might need to do the following. Max of descriptor byte size and descriptor alignment. Okay, item descriptor bit alignment. Okay, so that would be step, like yeah, let's call it step, and divided by 8. So the point is that we can have the types that are smaller than their alignment, I think, theoretically. So that's what we need to take into account for. Or not. Now I need to think about this. No, I think it should be taken care of inside of the descriptor, so I don't think we need to do this. Item byte size is descriptor by size of item descriptor. Yeah, I think I'm making it more complicated than this. I think that this will be taken care of. And I might figure out how to test it a bit later. Item byte size, where do you go? So this doesn't need to be happening. Field memory plus item byte size times I. Right, and then we can have item descriptor and depth plus 1. That sounds like it should work to me, but we'll see. Print, what is it called? R. And it does work. That's exactly what we would expect to see. Actually, that's not part of the debugger, but now I'm kind of curious if my inference works correctly. Can I just do this and will it still work? Print R. It does work. Cool. Yeah, so that's about it for today. I think that's quite good progress. We fixed the terrible bug that I had in terms of how to access stack and indirect pointers. We added printing of structs and we added print of fixed arrays. That is good. Guess it's all for now. Thank you for watching and hopefully see you next time.